Hi guys, today I'm going to present you the tutorial for learning VizDoom, the library from Much Vivid Move, if I correctly remember. Yeah, this is very nice library which allow you to play Doom with Python, and also there is integration for Gym and Gymnasium, like to reinforcement learning, like the same Gym, yeah, like the same. Also, you can integrate with gym or gymnasium, depends on version. So it's very nice place to start your journey with reinforcement learning because the scenarios are like there's a variety of scenarios, like environments you can play, and also you learn a lot about state, action space, reward shaping. So also I make this tutorial to make the whole process of installation and training easier. I find out like my idea was to move it to Colab with some limitations, but as you see now, even the model is training on Colab, but we go from the easiest one to more advanced topics. So this is not important now because also you can just go and use code from this this guy. Yeah, he have public repository and the code he write is quite good. I changed it a bit and also I put it on my recap with a bit of changes because he used the Deadly Corridor, but we will came to it a bit later. So let's see, it's recording. Yeah, it's recording. So we're going further. So first, let's see what we are talking about. So because Colab can only show you Google Colab, yeah, you have like different uh, cards. Like A100 is a very powerful card, but T4 was enough for me. Yeah, like 1.5 thousand, like 3,000,000 of steps, iterate like 4 hours, so it's quite good. You can put it and came back later or go sleep. Yeah, and also let's move further. So first, we need to import some libraries. My code is available on my GitHub, which will be linked to this video. Then we create environment with some configuration, like path. This is very important. This is not important. Maybe I will use different code to present it here. We have not this one. Yeah, like second is always better than first version. Yeah, first version of something is always not good. So here we have config of scenario, in this case Hello Gathering Supreme, and we have some uh, we have some R custom reward shaping, but let's begin from basic scenario when we have one monster and we're going left, right, and shooting. Why is grayscale? Because the idea is model can learn from grayscale and it doesn't need to learn it from different, like from colors. You can see difference between training with color and without color. So it takes 30% more time to train around like circa to train it with color, and like pink one is without color and blue one is color, so we see no effects training with color, so the grayscale can save some computer power. Also we have callback because sometimes model can stack with some optimum and the result can go down, so we need to have callback function to do it. And also we use CCN policy from stable baseline models. Yeah, like this is very good libraries, and it allow you to focus more on just doing reinforcement learning, not about training or writing your own functions, but you also can make your custom policy here. And also what we here, we have reinforcement learnings, which say how fast model is learning. So if it's too big, he can like be very different, and too small he can stack. Number of steps is how big model, how long model looking in the past. And without further talking, let's see this model. So for interactive models, you need to run locally it. Yeah, because you cannot do it on Colab because Colab don't have uh, graphic libraries. So we can see that we have actions, we have state of game, which we can print the state. So let's go see. Okay, this is not important. Yeah, it's just pixels. Yeah, we have game variables. So this is how many left ammunition in this case. And also we can make action. Yeah, like go left, for example. Yeah, it's tuple. Go right. These four mean how many we skip frames because we don't wanna do like each iteration, so we skip some frames and we just make add reward for these lacking frames. And now let's try to kill monster like by ourselves. Yeah, we have monster and the episode was finished. So we close the environment, it's okay. And now I already trained the model on Colab. Yeah, I attach my disk and I download it locally, like this train model. So now we can see the results of this training of this model. So uh, wait a sec. Yeah, here once more. Yeah, we have PPO is not defined. Why it's not defined? Yeah, now it should work. Yeah, now we're loading our models. VizDoom is not defined. Wait a sec, because I didn't use this code for a while for this easy one. Yeah, because I forget to declare this. It's work or yeah. We need a wrapper for this environment, that's why it doesn't work, but I also hope it's more interesting to watch because not everything will work in real life. And we will see me debugging this stuff. Okay, Windows right arrow, and we going or no? What is a problem? Okay, so basically doesn't work, but I will show you just different ones. Yeah, it's good. I have like backup plan for here, and it's very good tutorial in Korean.net and basic. It's not my focus of this study, so I will just keep basic scenario because it's really easy to learn. And we already show how it works. Yeah, I played myself. I don't know why model doesn't learn, but you can go always on YouTube and try to find some reinforcement learning scenarios. And here we are, Nicola.net, very good resources. If I didn't forget, I also will link it, this video, and we see how basic is trained on his site. But now we're going for something more interesting for me. So let's go to see visual health. This should work. Yeah, I didn't test basic one before this video, but this I used quite a lot. Yeah, we can close it for now and we need a wrapper. Yeah, yeah, we cut a bit of information, make all action space. We can go left, right, forward, backwards. That's why it's 7. And as I mentioned, we import like But for baselines, this is half million steps duration. Yeah, wait a sec. Wait, wait, it doesn't work. And let's see it. Yeah, the floor is toxic, so model to stay alive need to collect this 8 hit. Yeah, on beginning the problem was that model stuck in corners and it cannot figure out how to turn around from corner. Yeah, we can see this maybe if I have this file. And this is important to mention, this is WSL. So under this is not Windows, is Windows subsystem for Linux, Ubuntu. I think the Windows is only stable version of Linux, so WSL is quite good. And here we can see different model, like copy relative path. We close this, and which I will show you different how it's look for most of the time, yeah, because it's very rare that something works. Most of time things doesn't work. So and still some problems. Okay, because we have different size of window. Maybe this one. Yeah, because also my friend do some stuff with this code for like group project, and I think he cut the window size. But no, still problem. I don't know why it's work with this previous one, or start working in general, or okay. So I cannot show you. We changed something in code, and now we cannot show you different one. So let's go for Supreme, yeah, because for in VizDoom you have also Supreme. Like if you go here in documentation, you have also Supreme help gathering, Supreme and help gathering, and you can go like left, right, move forward. Ah, I know there's a problem. I think with observation space in this code. Yeah, because we have here 7, not 3, so maybe this is a problem why it doesn't work. Maybe if we go here for 3 and try do it again. Now it will work. Okay, it's quite working. Let's cut it, close it. And then let's go with different scenario. Oh, it's still working. So, but you see that it's not that good as it was before. Yeah, but also the training steps is less. So maybe let's try with this second here. Let's try it will work. Oh, okay, it doesn't work. Something changed. I think my colleague tried to cut the sky. That's why it doesn't work. Okay, but we go further. So let's analyze the code for live gathering. And the change it was important to do was here. You need we will take health from the environment if health is higher, like information than on health is higher than health before, you just need to update this value, like, and this is 4 because 1 per one each move. like for each click of environment. It's from documentation of VizDoom. Yeah, like this award and minus 100 for that. And here is just award. I go with 106 because also from documentation. Uh, yeah, in the documentation it was 106 for killing the monster in different scenarios, so I just go with the same. And now we try to, and it works, so we leave it because it was work quite well, as you can see. Yeah, I know what I want to show you. I want to also show you Supreme because it's more complicated scenario. Yeah, like 1.5 million steps. And as you can see, yeah, it takes the 8 kit, and I think these battles are bombs, if I correctly remember, or no. Yeah, but sometimes when it take battle, it dies, so I think it's more, don't take in battles, but I'm not, I just don't know it. So as you can see, it's now stuck in the window and he can see nothing but the 8 hit respawn, so it's collected again. Yeah, and it like skip this battle. One time I see if it go with this battle, yeah, it dies, so it's bomb. So it cannot collect the battles, it can only 8 kit. So this is our VizDoom. Let's close it. Yeah, you close it here and you close end by finger. Because in Windows you can just task manager and kill it, but I can find it in VSL, the option. The easiest is killing it from code. And I just want to mention one env, which is the knee corridor. And all code I saw uses reward shaping. Yeah, like they make something like observation when it get hit. Yeah, like here. Yeah, you can see like taken damage, and this also make the reward function differ. The problem is now that there are changes, in my opinion, in the VizDoom documentation, and there is no information like get hit, ammunition, so it's not uh, it's not possible now with this version of library to still do it like the way they do it, and the knowledge is, for me, in my opinion, too sparse to learn it without this knowledge, so it's not solvable now, like the D corridor. That's why I choose take cover, and with some successes and some not successes, unsuccesses, like opportunities to grow. So let's see first take cover. Yeah, and then after we see it, we'll go farther with this. So here we have like he can go left, right, and avoid the shot. When I tested, there was like 63 steps left or right, like possible. Yeah, because I was thinking about making like reward function, which will punish him to going into corners, because in corner he cannot see diagonal shots. So yeah, in my opinion, it's not good, but the result was not satisfying, yeah, and we see it just with punishment for get hit, because not every hit make him kill. Yeah, I think he can take 1 or 2 hits before die. Yeah, but this is hard. Like I just run it and I just observe the hit counts. Yeah, and this is like my laziness, because in takeover this is punishment for get hit, but I just leave it from because I use code from Colab Gathering and I just changed here and here. And this is my try to make it centralize. Yeah, like for every step left, it's go like -1, every step right +1, so it means middle is 0. And this is parameter. Here I try like different one. I try to divide it to make it zero, but the training go down. Yeah, and nothing works. Yeah, like we can see here, yeah, like nothing was working, so it made no sense to do it. And with, without further ado, yeah, I think we will go heading to end the video. This is also nice. Last thing, now we're trying to do some stuff with Optuma, like Optuma library, which help you figure out hyperparameters. Yeah, but I just will not have time to discuss this discuss. Like maybe I just make different video just for like Optuna results, but I have now time, so I record this video. Hopefully you get some knowledge. I try to link all stuff I mentioned, also my GitHub. Yeah, uh, here is my GitHub, yeah, and you can see that here is this repository, like some descriptions, and there you have like free files you can just upload to your Colab and free works. And here is the basic scenario. Maybe I will upload it for different one because as we see there's some mistakes there. So you will, I will just put here free visualization files in a moment, and those are requirements for installing it with Conda, which I recommend to do it with Conda because Conda is quite, if you get know it, it's quite good to do it. So thank you once more for watching, and like hopefully you learned something today, and see ya.